Okay, so as we talked about in class the other day, we can often make some observations about symmetry within a graph in order to simplify the process. So we know that an even function is symmetric about the y-axis, or f of x is equal to f of negative x, which defines an even function. And an odd function is symmetric about the origin. So in this case, negative f of negative x equals negative f of x. Gives us an odd function. If f is even, we can see that the integral from negative a to a is going to be 2 times the integral from 0 to a. With an odd function, we can see that the area between 0 and 1 will exactly cancel the area, for example, from negative 1 to 0. So looking at these functions, we have that 4 minus the antiderivative of 4 minus x squared from negative 2 to 2 can be rewritten as 2 times the antiderivative from 0 to 2 of 4 minus x squared dx. So we know that that antiderivative is 2 times 4x minus 1/3 x cubed, evaluated from 0 to 2, which gives me 2 times 4 times 2 minus 1/3 2 cubed. So I have 8 minus 8/3 times 2, which gives me 32/3. The second one, because I recognize this as an odd function, is much easier. It's just 0. So many times we're going to need to set up our own integral, as it won't be explicitly stated. So as in example 10, if we're finding the area bounded by f of x is equal to 2x plus 1 and the x-axis between 0 and 2, that's the integral from 0 to 2 of f of x minus 0, which is the x-axis, so these are my y values, dx. Well, we can simplify this a little bit by just saying f of x, because when we're subtracting 0, it doesn't matter. So when we take this antiderivative, we have x squared plus x that we then evaluate from 0 to 2, which gives me 2 squared plus 2 minus 0, which is then going to be 6. Okay, so looking at example B, we are looking for the integral from negative 2 to 2 of the square root of 4 minus x squared dx. Well, hopefully you recognize that as the upper half of a circle. So we know that the area of the upper half of a circle is 1/2 pi r squared. And we know that our radius in this case is going to be 2. So we have 1/2 pi times 2 squared. So we end up with a value of 2 pi. I'd like you to go ahead and work on examples C and D for the final questions at the end of this video. And let's go ahead and move on to example 11. When the left and right bounds are not provided, we must find the limits of integration prior to any antidifferentiation, as shown. So we're looking for the area bound by f of x is equal to 3x plus 4 minus x squared and the x-axis. So we're going to start with f of x is equal to negative x squared minus 3x minus 4 is equal to 0. And I went ahead and factored that negative out to make it a little easier to solve. So we have negative times x minus 4, x plus 1 is equal to 0, which then gives me x values of negative 1 and positive 4. So now I can go ahead and evaluate my antiderivative, and we're integrating from negative 1 to 4 of 3x plus 4 minus x squared dx. That antiderivative will be 3/2 x squared plus 4x minus 1/3 x cubed, evaluated from -1 to 4. So again, we have 3/2 times 4 squared plus 4 times 4 minus 1/3 times 4 cubed minus 3/2 times -1 squared plus 4 times -1 minus 1/3 times -1 cubed. And all of that evaluation gives me an area of 125/6. Now we will finish the challenge problem in class. But I'd like you to go ahead and think through that one and see if you have some ideas. Okay, so it happens quite often that we need to manipulate the limits of or work with only the values of a definite integral. Luckily, this is fairly straightforward in most cases. So, for example, assume for some function f of x that the integral from 1 to 3 of f of x is equal to 5. So, with that, if we have the integral from 1 to 3 of f of x is equal to 5, does it make sense then that the integral from 1 to 3 of 2 times f of x dx is equal to 10? Well, if we rewrite the integral from 1 to 3 and we factor out that constant, we have 2 times the integral of f of x dx. Well, we know the integral from 1 to 3 of f of x dx is going to be 5, so 2 times that is obviously going to be 10. Now, if we look at the integral from 1 to 3 of f of x over 5, dx, well, we can see that we can factor out that 1/5 times the integral from 1 to 3 of f of x dx is then going to be 1/5 times 5, which is just going to be 1. And then as we saw earlier, if we have the integral from 3 to 1 of f of x dx, well, we know that's the same as saying negative of the integral from 1 to 3 of f of x dx. So that's just going to be -5. Now, looking a little bit further into the properties of the definite integral, if we have the integral from 1 to 3 of f of x dx is equal to 5, and the integral from 1 to 3 of g of x dx is equal to 2, and then lastly, the integral from 3 to 7 of f of x dx is equal to 9, we want to find the value of each of these. So if we have the integral from 1 to 3, that's 3 times the integral of f of x dx, plus 2 times the integral from 1 to 3 of g of x dx. Well, we know that that's 3 times 5 plus 2 times 2, which then would give us 19. So moving on, we have, this is negative the integral from 1 to 3 of g of x dx, plus the integral from 1 to 3 of f of x dx. So we have -2 plus 5, which gives us a value of 3. Now, looking at the 7 to 1, well, we know this is true, that the integral from 1 to 7 of f of x dx would be the negative. That'll be the negative of that. Well, now we need to figure out what the integral from 1 to 7 is. Well, we know that the integral from 1 to 7 of f of x dx will equal the integral from 1 to 3 of f of x dx plus the integral from 3 to 7 of f of x dx. So that means we have negative. The integral from 1 to 3 is 5. The integral from 3 to 7 is going to be 9. And this gives us negative 14. And our last example is going to be the integral from 1 to 3 of g of x plus 5. So we separate this into from 1 to 3 g of x dx plus the integral from 1 to 3 of 5 dx. We know that 1 to 3 is going to be 2, but we do need to integrate this, so this becomes 5x evaluated from 1 to 3. Our last example is the integral from 1 to 3 of g of x plus 5 dx, and we can see that we can separate this into the integral from 1 to 3 of g of x dx plus the integral from 1 to 3 of 5 dx. We know the integral from 1 to 3 of g of x is 2, but then we need to go ahead and integrate this second portion, so we have 5x evaluated from 1 to 3. So we have then 2 plus 5 times 3 minus 1, which then gives us a value